Hello and welcome. This is Dr. K, and today we're going to talk about runout and total runout. And I figured the best place to do that would be in the shop in the camp lab. So let's head over there and talk runout. Alright, so here we are in the lab, and I'm recording this after the fact because what I had found was it was just crazy noisy with the machines running. So here we're going to start with this part, and we're going to use this part as our example. And of course there's a few features on the part that we're going to deal with. We need to consider one of these features as a datum feature. That feature is our reference, and we're going to check that into the machine. And then there's these other features that we're going to measure. So I'm trying to show here and explain. And so what we'll do is we're going to use that really that silver surface there as our datum feature. We're going to check that up into the machine, and then we're going to measure some of these other features, measure the runout, and then measure the total runout. Alright, so we've shifted views, and we've got a dial indicator set up to where we can read what the measurement is in a certain cylindrical slice. And so let's see. So we're showing you we're going to measure this feature here. And for runout, we're just going to measure a circular slice in that one particular area. And we're going to spin the part about the axis. So let's just make sure that it's zeroed. So I check to make sure that we kind of zero things. And we're going to spin this part around. And so as we can see, we shift from 0 to about 8 thousandths. And essentially, as we spin that part around, that is the runout measurement for this part. Now, runout itself, as its own tolerance, we deal in singular slices. So here we move to a different slice, we measure. Again, we're going to move to a different slice and measure. And there I'm showing that we just about go plus 1/1000ths on that 0. We're really, really close. And get down to bound to that minus 8 to minus 7 thousandths. And again, singular slice. So each of these slices are independent of one another. We measure that extreme, and that particular extreme is runout. Now for total runout, we have to deal with the extremes on all of the slices put together. And so what this would look like is that as we're measuring a slice, we're going to take our positive and negative extreme, move a little bit, check the next slice, take that positive negative extreme, see if that extreme is further, and then if it is, we will increase our extreme and then move to the next slice. So essentially we're trying to measure the cylinder that's happening and not just the individual slices. Alright, and as I just roll in some B-roll, let's look at the symbol for runout. So here it is on the screen here. This is our symbol for runout. We're going to make sure that we give it a value and then also give it a datum reference. That's that surface that we're going to deal with, that we're going to use as our datum that we're going to put into the machine. The second symbol that I want you to look at is the total runout symbol. So here it is here. Same thing. Datum reference, total runout, and then what the tolerance is. So real quick video on runout and total runout. Hopefully this makes sense to you. It is a reasonably straightforward tolerance to understand as we look at how we would inspect that tolerance. Alright, so I think that wraps it up here. Hope you have a good day, and we'll see you next time.